Hey everyone, welcome to our t-test unit. So you're going to see a lot of formulas in your book this week. I'm going to walk through two things with you. I'm going to walk through the differences in the three types of t-tests we're going to discuss and when to use each one. And then I'm going to do screen share walkthroughs on PSPP for how to actually go through doing all of these with the computer software. So if you want to watch these first and read the chapter, that's fine. If you've already read the chapter and you're watching these, that's fine. Either way. What I want you to know is if you're doing the math formulas in the book and you're getting frustrated and you're sitting there thinking, this is exactly why I didn't want to take this class, I want you to know, as long as you know the difference for each, know the scenarios when you use each, and know how to do it on the software, you are going to be fine. I am not going to ask you to show by hand t-test calculations at any point this semester. Not on the midterm, not on the final, not for your assignment, like none of it. As long as you can do it in the software and as long as you know when to use each, we're good. Okay. I don't want you to skip the textbook chapter. All right. This is not permission to just totally ignore the math and say, okay, screw that, I don't need to do it. But if you're having a problem with it, know that working by hand calculations of these is not going to end up mattering towards your grade. I want you to know the theory behind it. But realistically, if you ever work in data analysis, if you're ever doing any independent research, this is just not something you're ever going to do by hand. All right. So let's get that out of the way. Sorry, sore throat today, need hot tea. All right. So the three different types of t-tests. We have a one sample t-test. We have a t-test for dependent means, which is also called a paired samples t-test. And we have a t-test for independent means, which is also called an independent samples t-test. Same basic idea, three different applications. So the first one, the one sample t-test, or the t-test for single samples, I think your book calls it a couple of times. Basically what this is like we've talked about so far in your textbook, they've given lots of hypothetical examples where you know information about the population. You know your population mean, your population variance. You can calculate your standard deviations and a lot of other things for your population because you have that data. In a one sample t-test, you have your information from your sample data set, but all you have from the population is the mean. You don't have the whole population data set. You don't know all the numbers. You just know the mean. Now, this does happen. It's not as common, but this does happen in some real world scenarios. And I will give you an example of one I've actually worked with. I've mentioned a couple times that for a while I did some data analysis for a nonprofit organization that worked with child abuse. One thing that I would come across a lot, the state of Missouri keeps some pretty detailed statistics about child abuse. They also keep those statistics very locked down. All right. Even though I had the clearances and the permissions and the checks as being like the designated research consultant for this organization in Missouri, running these numbers and helping write these grants for child abuse issues, I could not just call the state agencies and get their raw numbers. They wouldn't give them to me. They keep them pretty well under lock and key. A lot of times the best thing I could do is get the mean if I wanted to compare something. So I might have had the mean for the population of Missouri, the population of child abuse cases in Missouri, or the mean for specific counties, right, for the population within that county. But that's all I had. So I had my sample of data from the organization that I was running the numbers for, and I had the population mean from either the state or the county. And so I had to make this comparison only knowing the population mean, all right? Something equivalent could happen like if I did research for Drury. Information that you gave as an incoming student, your age, if you gave income information applying for financial aid, your high school GPA, whatever, all of that is in a database somewhere. I'm not authorized to access it. So even if I was wanting to do research, I can't just go over to the registrar's office and say, hey, give me everyone's data so I can run these numbers. I might, however, be able to call over there and say, I'm wanting to run some research. Could I please have the mean age of Drury Go students or something like that? So you might run into situations either because it wasn't published We might see this with census data also, right? We can log on and get some of the means and averages with census data. That word's hard today for some reason. We can't log on and get the entire data set, okay? So this is useful in situations where the only piece of information you have is the population mean, and you're still wanting to compare your sample to it. So in this situation of a one sample t-test, your population 1 is your sample, your population 2 is your population, and you're running this analysis. Here's the formula for it. Your textbook actually explains that very, very well, so I'll let you dive into that. I won't waste time just parroting the textbook information with that. The next one is the t-test for dependent means. Now we're starting to get into situations for data analysis you might actually do if you ever do a research project. A t-test for dependent means is also called a paired samples t-test. What this means is I have one group of people, I have information from a pre-test and information from a post-test. Let's return to my example with the meditation app, right? Maybe I have data about your sleep beforehand, before you did the app, you did the intervention, you used the app, and then I have your data afterwards to see if it worked. If we're doing a workshop, right? Maybe I'm doing a public speaking workshop or a test anxiety workshop. I do a pre-test before you take the workshop, see what your starting numbers are. We do the workshop. I take a test a month later to see if I give you a test a month later to see if it actually made a difference. So I have pre-test and post-test from the same people that I'm analyzing. This is why it's called a t-test for dependent means, right? Because the significance of the post-test, the significance of the second number is dependent upon what your first number was, right? Did you increase? Did you decrease? Did you stay the same? That's also why it's called a paired samples t-test in our software, because the significance of, or not the significance of, but because you have your samples where one participant is directly paired with another participant. It is far more significant what participant 37's time 1 score and time 2 score is than the time 1 score of participant 37 and the time 2 score of participant 85. All right. So I'm wanting to directly pair them up to see the difference. Now, the logic behind what we're doing here, if you think back to when we talked about some of the theory behind hypothesis testing and using a null hypothesis, what we're doing is we're not actually comparing our group to any other group of people. We're comparing them to an assumption that the broad scale population has a difference score of 0, okay? If I take a measure of your test anxiety and I do a test anxiety workshop, and then I test you at the end of the semester on your test anxiety to see if my workshop helps you have less test anxiety in your exams throughout that semester. I'm interested in your difference between time 2 and time 1. Did my workshop help? The way I'm going to compare that is by assuming for the general jury population, the score for test anxiety between time 1 and time 2 is going to be 0 difference. It's not just going to change on its own. Now, obviously, we know that there's some situations where that might not always be a logically sound assumption, and that's a topic for another time. But what you need to understand is for how the math is working out here and how the logic of our hypothesis testing is working out. What we're assuming is we're comparing the different score of our repeated measure samples with a hypothetical population that has a different score of 0. So we're going to do the same formula as a one sample t-test. We're just always going to assume that second sample's mean is 0 because we're interested more in the difference mean. And again, your textbook actually does a very clear job of explaining that. I think they explained t-tests more clearly than they've explained a lot of other things up to this point. The last one is a t-test for independent means. And what this is doing is your most common thing that you see in behavioral sciences research. We're comparing one group to another. We're comparing our experimental group to our control group. We're comparing men to women. We're comparing seniors to freshmen. We have 2 separate groups and we're comparing them. So a t-test for independent means. This is also called an independent samples t-test. because unlike this one, we don't really have scores that are depending upon each other in the data set, all right? If participant 497 is in sample 1, their scores in relation to, participant 211 scores in sample 2, they're not dependent on each other. Each one is functioning as its own entity. I'm interested in what group they're in, but I'm not saying that any of these are relevant to each other. And actually, if they are, I'll throw off my calculations. So here is what the formula for this one looks like. I realize that might be kind of blurry. My webcam is not focusing. But here is the formula for this, also very clearly explained in your book. So for your assignments this week, for your midterm, for your final later on, what you're going to need to know is, when do I use which one of these situations? So if I say, and make sure to watch the videos after this also about how to actually do this on the computer, okay? But if I say, I know the mean score of the Drury population when it comes to their stress level. And I know the samples, and I have a sample of English majors at Drury that I have evaluated their stress scores, and I want to compare them. I want you to be able to identify, okay, population compared to a sample, that's a one sample t-test. If I say, I'm going to compare math majors at Drury with biology majors at Drury, I want you to know that'd be a t-test for independent means. I'm comparing two samples. If I'm saying I took a group of criminology students and gave them this pre-test about depression and did an intervention and gave them a post-test about intervention, it's the same group that I pre and post-test, I would want you to know it's a t-test for dependent means. So I'm going to tell you a situation. You need to be able to identify which t-test we would use and also how to do it using the computer software, okay? And then also for your assignments and your discussions this week, I'm going to ask you to come up with hypothetical scenarios that you could use each of these. So if you have any questions, as always, email me or set up a time for virtual office hours. But that is a quick rundown of the differences of the three types of t-tests.